question number 8, you're asked to show that negative 2, 12 is a stationary point of that function. Once again, it wouldn't hurt to have a look at the graph involved there. And you can see we've got a maximum at negative 2, 12 and a minimum at 0, 8. It's a nice mental picture of what's required there. Now the first thing I've got to do, I've got to locate my stationary points. And they occur when prime, the derivative, is equal to 0. Factorising that, 3x to x plus 2 is equal to 0. Therefore, stationary points, x is equal to 0 and x is equal to negative 2. The next part requires me to use a change in slope diagram, a change in sign, in order to show that the nature of the turning point of x is minus 2, probably going to be a maximum. So what I'm going to do now, I'm going to do a change in sign diagram. I'm going to include both the points 0 and negative 2. Zero and 1 there, and a little bit of substitution to help me along my journey. So I've got my two stationary points by definition. And when I plug in negative 3, I end up with 3 by negative 3 squared plus 6 times negative 3, which is going to be 9. So positive to 0. And when I plug in the negative 1, I've got 3 take 6, which is negative 3, 0. So therefore, stationary point, negative 2. And in the question 12, your sign goes from, or dy over dx, goes from positive to 0 to negative, so therefore a maximum at negative 2, 12. In turn, if I was to do that for 1, I would find that would be positive 9. So my other turning point, which is 0, 8, I'm actually doing part C and D here. That will be a minimum. Because what happens is we've got a change in sign from negative to 0 to positive. So that really answers C and D as well.